So let's look at these two triangles off to the right. We have triangle APQ, which is this top triangle, APQ, and triangle ABC, triangle A down to B down to C. All right, if I were to draw those separately, we have, APQ, which is going to be 8, 9, and 3. And we have the big triangle, which is ABC. The whole side lengths are 16, 18, and 6. All right, so what do we notice is going on here? Well, the smaller triangle is half the size of the big triangle, right? 8 is half of 16, 9 is half of 18, 3 is half of 6. And in this diagram, P, this point right here, the point P, on either side of it, that side length is broken up into 8 and 8. So those sides are congruent, which makes P a midpoint. What about Q? When I plot Q, it breaks up AC into two parts, both being 9, which means Q is also a midpoint. All right, PQ, which is half of the third side BC, PQ, since it connects the two midpoints, is called a midsegment. All right, so a midsegment is a segment that connects two midpoints inside a triangle. All right, so this is an extension off of our previous lesson, and we'll get into why in these two theorems. Okay, I'm going to do the second theorem first. This midsegment theorem is parallel to the third side. So if a segment joins two triangle sides at their midpoints, making it a midsegment, then it is parallel to the third side. All right, so like in this problem, we see that DE is parallel to BC. All right, which we dealt with in our previous video. All right, if we have a side inside of our triangle that's parallel to the third side, it's going to split those sides proportionally. A midsegment is a type of parallel side that's very specific because it's going to split the sides, and it's going to, where it connects those sides is going to be midpoints. All right, so the midsegment is going to break those sides into two equal parts. All right, and the other situations going on is that the midsegment is going to be half the third side. All right, so if a segment joins two triangle sides at their midpoints, making it a midsegment, then its length is half the third side's length. All right, so DE is going to be half of BC. Okay, or we can set up this ratio of midsegment over third side equals 1/2. DE over BC, the midsegment over the side, is going to equal 1/2. So that's a proportion that we can set up. Those are two ratios we can set equal to each other in order to cross multiply and solve. All right, so a midsegment is just a specific case of what we were talking in previous videos, talking about the side splitter theorem. All right, so let's look at example 1. In each triangle, M, N, and P are midpoints of the sides. So M is a midpoint of CD, which means that each of those, it breaks those into two equal parts. P is a midpoint of CE, breaking that into two equal parts. And N is a midpoint of DE, making that into two, making those two parts congruent. All right, name the segment parallel or the length to the one given. So CE is this third side here. So what side length is going to be parallel to CE? Well, the midsegment that goes with CE is MN. Okay? Next up, we want to figure out what is DE equal to. Well, DE is this entire segment here. All right? Its midsegment is MP, which is 8. So what do I have to do with the midsegment in order to get the third side? I need to double it. Okay, so 8 times 2, DE is going to equal 16, making NE, this part right here, half of 16. It's going to be half of 16 because N is a midpoint, so it's going to break that 16 into 2 equal parts. Okay? When there is a midsegment, kind of what we were talking about in the previous video, when there's a midsegment, 2 similar triangles are created. All right, and I drew those triangles separately up here, so I'm going to copy these down. I'm going to copy those down, that way we drew them separately. So AP matches up with AB, just like AQ matches up with AC, just like PQ, the midsegment, matches up with the third side BC. And in each of those cases, those ratios are going to simplify to give me 1/2. Small triangle over the big triangle is going to equal 1/2. All right, so using that idea of midsegment, all right, it connects 2 midpoints, so it cuts the sides into 2 equal parts. It's parallel to the third side. The midsegment is half the third side, so we can either set up an equation like midsegment equals half times third side, or a ratio, 2 ratios into a proportion, like midsegment over third side equals 1/2. We got a couple different ways we can solve for it that way. All right, and the other big thing is that you have 2 similar triangles. So sometimes it might be helpful to draw your triangles separately in order to set up some problems. All right, so midsegments connect 2 midpoints, and then it's got certain criteria and certain theorems and certain concepts that follow because of what it is. All right, so I've got the you try now problems here for you. Make sure you give those a try. Check out the worked out notes in Schoology so that you can see the correct answers. Let me know if you have any questions, and make sure you practice, practice, practice.